Hi, my name is Joshua Kuhn, and today I'm going to be going over the prototype design pattern for my chosen design pattern. The intent of the prototype design pattern is this pattern is used to avoid subclasses of an object creator in the client application, similar to what the factory method pattern does, in order to avoid the extensive costs of creating a new object in the traditional way. Traditional way being using the keyword new in order to create new objects. And this is very similar to what the factory method pattern does because, of course, like the factory method pattern, this is a creation design pattern, which is used for creating new objects. So for the structure of the prototype design pattern, here are some sample UMLs, one being class diagram, the other one being a sequence diagram. And so we can see in the class diagram, we have a client interacting with the product and the prototype. And the prototype being the main part of the prototype design pattern works with this main method clone, which you'll see being used throughout the whole thing. And as you can see, a product is created by calling the prototype and cloning it. And from there, we have inherited from a prototype. We have product one, which inherits the clone method as well, which allows it to therefore then create a copy of itself, product one, which then is inherited through product, which works with the product. And as we see, the sequence diagram, very similar to how in the class diagram, first the client using the clone method interacting with prototype product one. From there, prototype product one is then passing on that clone method to product one. And now, more detailed UML diagram that's going to be more responsive to my demo application. And I'll apply my demo application to this UML diagram. So as we see, the client and its operation, this operation being creating our object P equals prototype.clone. And then as we saw in the previous UML, similar. And then from there, we have the prototype, which as we see has that main method clone, which can be seen throughout all. And so my prototype for my demo application is going to be shape. For my demo application, I'm working with shapes, and shape being the main prototype, and then my concrete prototypes are going to be types of shapes. So circle, square, rectangle, that such thing. So for prototype, it's going to be shape, and then clone method, and then from there, my concrete prototype one and two is going to be circle, rectangle, and then three would also be square. That worked with three. So and then this clone method once again is just returning a copy of itself to create the object. And now I'm going to be jumping into my demo application before I look at the consequences of the design pattern. So as you can see, my main prototype is going to be class shape. And so the only method that actually is like directly required for the prototype design pattern is going to be this first one, this clone method here, which clone method is for creating copies. So we'll see we have a pointer of our original prototype clone, and from there, const 0, of course, and from there we're creating a method that allows us to create copies, which we'll see will be used throughout the whole code. And here we just have a simple printing method draw, which kind of prints out the dimensions of the shapes. And then lastly, for prototype, we just simply have a virtual structure for proper cleanup of the code, working with objects. So now we have our first concrete prototype, circle. Circle has its own specific attribute, radius. That's not going to be seen in any of the other classes. And then we're just creating a simple constructor, which consists of that attribute. And from there, we're using this clone method, but we're overriding it to ensure that we're creating a new instance of circle. And we also are ensuring we're using this to ensure working with this specific initialization to ensure we're overriding to allow us to create more than one circle. And then lastly, we have this draw, which I kind of pointed out, is just kind of printing the dimensions of the circle. or of the corresponding shape in which you'll see it'll be used for others. So now we have rectangle. This is going to be our concrete prototype 2, inherited from the prototype. And here we have its own respective private attributes that are going to be only within rectangle, none of the other ones. And then you see create simple constructor consisting of the two attributes. And once again, we are overriding the clone method to ensure it is working properly for rectangles, because we don't want to use the clone method of the circle for the rectangle, because obviously that'll cause a lot of problems. So we're overriding every time to ensure it works for that specific instance. And then lastly, once again, draw similar to circle, kept its diamonds with the rectangle with the width and the height. And lastly, we have square, which goes to the same thing, has its own attribute, creates its own constructor with set attribute. From there, we are overriding the clone method once again to work properly for the square, for the particular instance of a square using the this keyword. And then lastly, with the same print draw with the square. So now here, the main method, which this is gonna be acting as the client application. So here we are gonna be, as seen before, we're gonna be doing this, creating these objects, and then from there, gonna be cloning them in order to actually fully instantiate these objects. First, we're gonna create a circle prototype from the circle class with a radius of 5. Then do rectangle with the two attributes, ensuring we're fulfilling those parameters. Circle having side length of 3, and then we are creating another circle prototype to show that we are able to have more than one instance of a class, to ensure that there's no problems with having more than one instance. And then from here, we are creating the shapes itself by calling that said prototype and then cloning it. And they're using their respective clone operations. So they're using circle, rectangle, square, and then circle once again. And then from here, this draw method allows us to print to actually visualize our results when we're running our method. So as you can see, everything works properly. We have see all our corresponding draws. So for a circle, we're drawing circle with radius 5. That's correct. And then all the other ones are correct once again. And then this is important. We see drawing a circle with a radius of 6. That's essential because it's good to see that we're able to have more than one instance of circle, and it is working properly, so that this isn't radius 5. It isn't stuck with the same instance of circle. So that is demo application for the prototype design pattern. And now I'm gonna be going over the last of the prototype design pattern with the consequences. So first, for the consequences, we're gonna have advantages. So for the advantages, first we have efficient object creation. So for object creation, the reason why is it efficient and it's advantage because it allows you to create an object by copying existing ones, instead of having to create objects by copying. I mean, instead of creating objects by making them from scratch, you're able to copy existing ones, saving a lot of time, things like that. And from there, this kind of correlating with the first point, flexibility. This allows you to create objects in different configurations, either copying, as you see before, or making an object from scratch if you have to. So it gives you that different option, different flexibility, so whatever is going to work best for your code. And from this, you're able to reduce the need for complex initializations, because you're able to copy in some situations where if you didn't have that ability, you would need very complex initializations. And lastly, reduces code duplication. For that, it reduces it because we are essentially centralizing the creation logic in one place, in the prototype class and shape. So you're not having to have a bunch of different creation logic in all of your concrete prototypes. You're having it in just the main prototypes. That's It's nice for reducing code duplication, so you're not just writing the same thing constantly. So now for our disadvantages. Um, One disadvantage is complexity, especially if you're working with deep copying instead of shallow copying. If you're working deep copying, you're getting a lot more detail, and in turn, that becomes a lot more complex. For and then for not suitable for all scenarios, um, the specific scenarios that this may not be suitable for is either circular references or complex interdependencies, where one class is relying heavily on the other, and from there, copying it just becomes essentially a hassle and too complex. So it's easier to create it from scratch. So you're making sure you touch bases on all those complex interdependencies and not missing them in the copy. And lastly, a disadvantage for the prototype design pattern is memory usage. If this prototype design pattern is not managed properly, cloning an object can lead to an increase in memory usage and potentially even memory leaks if you're not properly handling the cloning object. Make sure you include both your constructors and your destructors to be able to delete objects when necessary. And here are some real world applications for the prototype design pattern. For example, for spreadsheets, say you're working with spreadsheets that contains many cells, and you're wanting to some of them's working with numbers and other ones working with addresses. It's similar concepts. By using the prototype design pattern, you're able to set up templates for these cells, and that allows the process to be a lot easier instead of creating everything from scratch. So templates of everything, especially spreadsheets, is very essential. So you're not having to do every small little detail. You're able to just do the important stuff. And then another world application that could apply for the prototype design pattern is document management system. So for a company, said you say you have a various amount of documents, and you want to be able to set up a system where you're able to have a main template, and then from there create various different interactions. So for example, like important documents, and then for work, say you have contracts, resumes, cover letters. So each of those would be a concrete prototype from the original, just being like a main work document. And then lastly, a very similar concept for a rural application would be record management for people associated with the university. So your prototype could just be people associated with the university. And then from there, your concrete prototypes would be specific people. So students on campus, professors slash teachers, potentially even donors. So by being able to have a basis, a prototype, people associated with the university, and then creating specific concrete prototypes, it's a lot easier to manage and store things rather than creating things from scratch and just a lot of repetition, essentially. So by setting up these systems, you're reducing the repetition and you're making things a lot more efficient and simplistic. So that is everything for the prototype design pattern. Thank you for listening.